Assalamualaikum and hello everyone. My name is Muhammad Daniel Putra bin Shahrul Nizam, metric number CE200225, and I from group 7 in section 2. So today I will explain about lab control, which is experiment 6, proportional integral derivative control system, which is PID. So today I will explain for my part, which is part B, feed forward and feedback control. So the first one, open the PID controller tuning in Simulink, run the system and analyze the engine speed RPM when different speed reference are used, and then analyze the engine speed when different PID parameter are used. So I will demo the result to the lab instructor. Right, so the first thing, we open the MATLAB. Okay, after we open the MATLAB, we click the Simulink. So this is the block diagram that I have been arranged. So if you want to put the block diagram step, sum, PID, we just click the library browser. Okay, so we just search step. So this is the step that I choose. Right, so same with the sum, PID and the all. Okay, so this is the transfer function, which is 1, 12 and 20. So the PID, I put it P is 5, integral is 10, derivative is 35. Right, okay, so the step is step time, I put 2, initial value 2000, final value is 3000. Okay, so after we arrange block diagram like this, we just click run. Okay, so we can click the scope to see the graph. Okay, the graph is like this. Right, so then we change the step time into 4. Click apply, and then we run. Click the scope to see the graph. So before this, the result is at 2, and then it changed to 4. Okay, so we choose another step time. We put 6. Then we run. Okay, we see the scope. So before this is 2, at 2, then 4, and then at 6. Okay, so this is for the number 1, open PID when the different speed reference are used. So it's for the number 2, analyze the engine speed RPM with different PID parameter are used. So different PID, which is we change this PID into PID, PI, PD or B. So we choose PID, and then we change this to PID tuner apps. We click apply first. After we click apply, we click tune. Okay, so we see the graph is like this. We can, in this PID tuner, we can adjust the response time. We can also adjust the transient behavior. Okay, so if we want to see the parameter, we just click the show parameter, and then it will show the performance and robustness. So we can see the rise time, settling time, overshoot, peak, gain, margin, phase margin. So this is the tune, this is the block diagram. Okay, so next we just change PID to PI if you want to see the PI. So this is the two, and then we click apply, click tune. Okay, this is the graph for PI. Alright, so and then for the same with the for the PD and PI also. So that's all for me for my part, which is part B. So thank you.
Assalamualaikum, my name is Muhammad Faiz bin Hamidun, number matric DE20024. Okay, today I want to show you how to do the part 2 for PID control experiment using trial and error. Okay, we have to do for P controller, PI controller, PD, and lastly PID. Okay, let's start. Okay, first we have to use MATLAB and then open the Simulink. Okay, first we have to find this component, step, sum, PID controller, transfer function, marks, and scope. Okay, first we have to change the step. This is for step time 1010, and then we go to PID controller. Okay, this is the controller P, and this is the unit, so we have to change to 2, and then we click apply, then OK, and then we click run. Okay, then we click the scope to see the graph. Okay, this is the graph, and this is the data overshoot. Okay, next we repeat the step for PI controller. Then we have to change the value. Click apply, then OK, then click run. Okay, this is the graph, and this is the data. Okay, next we go to PD controller. We repeat the same way to get the PI controller. We just change the value. Click run. Then we got the graph. This is the graph. Okay, and the lastly is for PID. Click run. Okay, this is the graph for PID, and this is the data. Okay, that's all from me. Thank you.
Hi, my name is Muhammad Sharif with matrix number CE200077, and now I will proceed to present for the PID control experiment using the auto-tuning method. This is the controller P, and this value for proportional is 2 based from the try and error method. Then I will tune it. This tune will be done by automatically, and we show the new graph compared to using the proportional equals to 2. And this is the graph. This one right here is the graph that has been auto-tuned, and this one is the try and error graph. And now I will show you the parameter. Here you can see the original one is 2, and now it's tuned the p-value to 12.64. You can see the rise time is faster than the original. Also the settling time also is faster, but it got a little bit overshoot 16.6%, but which it gets to the peaks which 1.01. Now to show the graph on the scope, we update the block so it will change the P to the new value which has been tuned. And then here is the scope to show the graph. As I run the simulation, you can see the graph will look like this. Then proceed to the second controller, which is the PI controller. Based from the try and error which we want to compare with the auto-tune, we set the proportional as 4 and the integral is 0.1 here, and then we press apply and tune it to see how it will tune a better result, maybe better than the try and error. So this below here is the previous graph if we use the value from the try and error, and this is the tune one to show you how they change the PI. I will show you the parameter, and you can see here the new P will be 3.3142 and the new I will be 9.8256, which you can see here the rise time is a lot quicker, which is 0.368 seconds compared to the previous try and error, and the setting time is also a little bit faster, and the overshoot go for 10.4% and the peak is 1.1. Show the graph, I will update the block using the tune PI. You're waiting while it's running, and this is how the graph will look like when we use the tune result.
My name is Eliwan Aminon with magic number CE20162, and now I want to continue our presentation with part 4, which is PID controller experiment using auto-tuning method. In this part, I will conduct this experiment by using PD controller. So we go to our Simulink. So this is our circuit by using Simulink MATLAB. So we can see here this is our state, this is our sum, and the most important is PID controller. And this is our transfer function, and this is our scope for output signal. And for PD, we click this PID controller. Then after that we change this controller is PD and change the value of P proportional is 6.4 and for derivative is 3 here, and then click apply and then OK, and we try to run the script. So this is our signal for PD controller. So in this part we use the tune to know the signal and we know the settling time. So this is our PID tune for PD controller. So we can see here the parameter here. We can get the settling time is 1.31 seconds for tune, and for block is 0.757 seconds, and then for rise time is 0.353 seconds, and for block is 0.484 seconds. So that's all for PD controller. We move to PID. For PID controller, we click this PID and we change the controller is PID because we want to know what is the signal of PID, and we change the value of proportional is 8 and for integral is 2 and derivative is 3, and then we try to run the circuit. So this is our signal output for PID controller, but for part 4 we need to use auto tuning method. So we click this one and we go to tune here. And then we can see the signal for PID controller in tune. So we show the parameter here. Then we can see the settling time is 4.75 seconds and for block is 5.12 seconds. Beside that, we can click this response time to adjust the settling time, then make sure the settling time is under 5 seconds. So that's all for PID controller and PD controller in part 4. That's all for me. Thank you.